looking at this page. So what did I say to do when you have the same letter on both sides? You just have a single letter, like X or whatever. What do you do on decimals to make it work? Yeah, you plot each side independent of each other. So you take the left side, make that a y equals, and then you take the right side, make it a y equals. But the only one right here is just we have to modify number 5. So that's just an algebra 1 thing. You kind of squeezed in there. So let's just hit number 5 real quick and then see how the rest. So this one we want to solve for y. So subtract 3x. Negative 4y equals negative 3y plus 12. Divide by 4. So that's going to be 3 over 4 positive, and that's negative 3. So that's the only one that's a little different. Agree? And then we started talking about the interval stuff down the bottom. But up through number 12, how do you feel they went for the ones that you tried? I didn't ask you to complete it. I just wanted you to try some. Did you feel comfortable, or was there any that were, a little awkward how they stuck out? Dim the lights, give us a nice ambient. Maybe we'll have violins. So they were all pretty good. Kind of creative. Aren't you now mad at your algebra 2 teacher because you didn't know how to? They didn't let you do it that way. So let's move down to the bottom of this page. We did the first one, right? We did that 13. Well, let's take a look, make sure we feel comfortable with 14 and 15 done the same way. And again, Desmos works very nicely with us to do it. If you need me to go back to a problem, we can. Oh, sorry, that's my med class. There's only 80 people in there. Any of you in the med class? Nobody? Okay. All right, so number 14, I'm just going to go ahead and graph y equals parentheses 3x plus 1 and 2 plus x. And let's make that a little darker so we can see it a little better. So the second one you want to do is they tell you, hey, we want it to be less than 0. So I'm going to go y, and I'm going to use the inequality signs, and we're going to use less than, and you get that. Okay? So less than 0 is that blue region. So the blue region is where we want, all we're doing on here is we're indicating the, hey there, we're indicating where in our domain where that would take place. Okay? So I need to make this one I need to figure out those 2 dots here and here. So I just take Desmos, click on them, and it looks like it happens at -2, and it also happens at -1/3. Yeah. Was it 2 minus x? I think you're right. We can change that now. Okay. Is that more what you're saying? Okay. Sorry about that. Okay, so this is going to change those, which is fine. So this -0.3 repeating forever is the same thing as -1/3. You feel comfortable with how I establish that? And then 2 is 2. So we're going to talk about the domain. So the domain for this particular problem, I'm going to have -1/3 and 2. So I have -1/3 and I have 2. And so this is going to go from -infinity to -1/3. and then from 2 to infinity. Now, the reason why everything is a parenthesis is that when you're dealing with intervals, a parenthesis is a soft bracket. It means you're approaching a particular portion. You're not getting exactly there. Okay, you never get to the infinities, so the infinities will always be a parenthesis or a soft bracket. And then the negative 1/3 is a soft bracket because we had just less than. And then the 2 is soft bracket. And again, that's talking about, let's go back to the Desmos. So what's happening is I'm talking about what's going on in the right-left direction, left-right. Okay, so from negative infinity all the way up to negative 1/3, it is less than 0. It's below the line. And then from 2 to infinity, but the 2, because we have the less than sign in there, we didn't have the less than or equal to, that would have made it a soft bracket. If I would have had this as less than or equal to 0, where this line would have been solid, you would have changed your domain at the negative 1/3 to a square bracket, and at the 2 would be a square bracket. Okay, so that's where that would have changed a little bit. Questions about that? And then we have this one. Okay, so difference between 15 and 14 is my inequality sign is less than here. It's less than or equal to here. So you're actually going to use that on Desmos, and it'll work nicely for you. So I'm just going to go change this. I'm going to go 2x plus 1 and x minus 5. And then I can change this from that sign to less than or equal to 0, and now it becomes a solid line. And so this is going to go from negative infinity to negative half, because negative 0.5 is negative half, and it's going to go from, this is where we want it equal or less than 0. So we're talking about the region in between here. Okay, so this particular one is going to look like this. And that is where the domain, the x values, if I were to plug in, is where it would be below, in this case, the x-axis. And that's how you can walk through all those problems. Notice this one doesn't deal with the infinities because you're talking about in between those. And when you look at the graph, you're like, okay, the portion of the graph that is below in the blue region is in between negative 1/2, and we include that point because you have the equal sign, so that's the square bracket up to the 5. Okay? All right, and then when you take a look at the back page, so 16 through 21, these are really nice to do because these are a little bit more complex. You have a really kind of a goofy looking these all have exponents affiliated with them. Agree? You're still going to do this the same way with Desmos. You're going to have the left side as y equals, and you're going to have the right side as y equals. So if we were to take, say, I don't know, pick one. Which one of those you'd like to see? And I know this says solve using logarithms. We're not going to do that. We're going to use Desmos. Any of those you want to see? How much? 21. You got it. All right, so problem number 21, you're going to have y equals 3.6, and that's going to be raised to the, and it might be important to put the exponent in parentheses so nothing drops back down. It might work without the parentheses, but you'll always be safe with that. So that's what the left side graphically would look like. The right side, we're going to go y equals 47.2. And then on Desmos, you have to come up here, and hopefully you can see a green and a purple line. All you're going to do is you're going to click right here. We're solving for x. We don't worry about the y component. We're just solving for x. And so in this case, 1.505 rounded to 3 decimal places would be the answer. So if you plug 1.505 into the x, you should get very close to 47.2. The reason it's not going to be exactly there is because it's we rounded off. Yeah.
Sorry, mine was y.
Yeah. Okay. So you're really small. Yeah.
My line like curves.
Your first one does? Yeah, it should. It's an exponential equation. So, all right, cool. Yeah, that's what it should look like. And then I have to kind of come down here. Find that 47.2. And then take that back to normal. It says and button and takes back to negative 10. You guys get that? Seems simple enough. All right, so today is Wednesday. That means tomorrow is Thursday. Good to see you, brother. So, would you take the opportunity to give these a good try? See if you can make it work. If it's getting goofy, come talk to me, and we can take care of that. And I was thinking Friday is real life math. Let's see. What would be a good real life math? Why don't I show you all, even though we're not in tax season, why don't I show you what the gradual tax table looks like and how it works? And I will tell you, everyone has heard, oh, this person doesn't pay their fair share in taxes. I will tell you what, when you look at how the tax table works, there isn't one person that makes over $11,500 a year that doesn't pay their fair share in tax, according to the news. I can assure you, I don't pay the fair tax. Okay? Because they exploit it. They'll say, oh, they should be at the 35th tax, they should pay 35 or 32% or whatever the tax table is. It doesn't work that way. It's a gradual tax table. And so it'll kind of be somewhat enlightening to go with that. And I think just for planning purposes, I would say tentatively Thursday next week, or probably Thursday next week, we will do our first test. Deal? And we're gonna work on it all together. Yeah.
Do you do like quizzes too, or just tests?
Yeah, sometimes.
Okay.
I kind of go all over the place.
Okay.
So I don't have any rhyme or reason. What do I do? And what I do if I realize people did poorly on a test, I'll make sure there's a quiz that's in the same category that's easier, so we inflate grades.
Okay.
Yeah.
You get to use this on the test.
Yes.
Okay.
Yeah. You get to use each other, and you get to use technology. You get to use your phones. Does that stop you from saying, I'm going to ChatGPT? No. I mean, I said, I want you to be familiar with information. I will tell you, if I was working in the corporate world, and it's like, hey, we need to try and analyze this problem, I might jump right to ChatGPT to get it answered. Now, I warn you, it's not all the time is ChatGPT going to do that, and I might say, hey, what is the second step? And I realize that ChatGPT is going to solve this problem, so it can show me all the steps. And you can do it, which is great, but just realize technology is a really cool thing, and it's so funny to me that so many educators are saying, oh no, I'm going to get away from it. Well, my thing is, I want you to recognize that I would imagine in your work field that you choose to do one day in life, it's gonna be helpful for you to make problem solve for your businesses that you work for, or they run. Cool? Any questions for me? So finish this whole front, whole back for tomorrow. We'll go over any questions you might have. Deal? Everyone happy? No one gonna lose sleep tonight about it? Sweet. I'll stop my recording. Probably the